Welcome back for another lesson in Math 8. Today we are in Unit 3, Lesson 9. Slopes don't have to be positive. We're going to find out what it means to have a negative slope, also to have a zero slope. First thing we would start out with is which one doesn't belong. Odd line out. Take a look at these lines. We have 4 lines here, and we have to decide which one doesn't belong. To make sure that whatever you do when you choose one, you have good reasoning for why you've decided that line doesn't belong. Now, perhaps of these 4 lines, the one for me that stands out the most is line V, because line V comes down and to the right. It's different than all the other lines. It doesn't come up and to the right like all these other lines. So the other thing that I could see on here is I would say the line U doesn't belong. It's the only one without a slope that's of 1/3 or negative 1/3. Line T isn't even the same color. It's not a black line. It's just dark gray. The idea behind this is that you can actually pick up any number of reasons for why one line doesn't belong. You just need to have solid evidence for why you would choose to not include it. 9.2 is stand clear of the closing doors, please. There's an interactive version available if you would like to go ahead and put this onto that graph. Just plug in that URL. Here's the situation. Noah put $40 on his fare card. I'm going to stop right there. This is not like a fair that we go to where we see animals and things like that. In bigger cities, there's public transportation, such as riding the bus or the subway or something like that. And you have a card that you continue to accumulate your money on. Use it kind of like a gift card where you put money onto it and you use it, or like a debit card to pay for each time you ride the bus or whatever it is. In this case, every time he rides public transportation, $2.50 is subtracted from the amount available on his card. So we would see this every time he rides, it's $2.50 that is subtracted from the available amount on his card. So how much money in dollars is available in his card after he takes, sorry about the work on here, 0 rides, 1 ride, 2 rides, and X rides. If you recall in our previous lessons, we have written equations that can help us out with this stuff. So let's figure out where it was. In our previous lesson, we talked about this y-intercept, or the initial value. So when we talked about the initial value, we talked about Noah started with $40. And every time he rides, he spends $2.50 per ride. So what we'd have to consider with that is that this must be a subtraction. And all of that would be equal to whatever is on his card. So we can say Y would be the total amount of money on his card, and X would be the number of times he rides. Y be, we'll call it balance on fare card. Balance just means how much money is on the card. So we are going to use this equation to help us out with these other pieces. Now let's think about it for a minute. If he's going to ride for 0 times, we'll put our equation right here. If he's going to ride 0 times, well, then it's not going to cost him any money. So how much money does he still have? He still has $40. What if he rides 1 time? Well, then that would be, our equation would have to be started to be used, and it would be $40 minus $2.50 times 1. 1, because we know that the number of rides is our X value, and so we're going to substitute that X value in. So we can just simplify that and say 40 minus $2.50, which means that his value on his card would drop down to $37.50. What if he went on 2 rides? Well, again, we're going to go with this $2.50 times 2 now, because we've changed our input a little bit. And then we see that that's 40 minus 5. So that our Y is going to equal to $35. So if we talk about any number of rides that were out there, we come right back to our equation, and we see that Noah is going to have $40 to start on his card. He's subtracting $2.50 every single ride that he takes. This is not the only way to write that. You might be saying, well, gee, that doesn't look like Y equals MX plus B. The order is switched up just a little bit. You are certainly welcome to go ahead and write this as the m part first, but we have to understand the m part, meaning the slope or the rate of change, is a negative value. And so we have to have a minus $2.50 times x plus 40. For me, I just prefer to write it this way because it makes more sense to me. When we talk about graphing the relationship of any amount of money on the card and the number of rides, we can come right back to a graph to see exactly how that's set up and to see what it looks like. So remember that we had an initial value. When we talked about 0 rides, he had $40 on the card. So we can start with a point right here to decide that this is how much money he has. But I want you to watch and see what will be interesting about this. After 1 ride, we drop down $2.50. We notice on the y-axis we are at intervals of 2.5 or 2 5/10. We can see the drop goes 5, 10, 15, 20, goes up by 5s every other line. And so we can see that we're going in a motion like this: 2 rides, $35, 3 rides, 4 rides, 5 rides. We can figure out exactly how many rides will happen over any amount of time. So the question is, how many rides can Noah take before his card runs out of money? Where do you see this number of rides on your graph? Well, if Noah runs out of money, that means that the dollars on his card will eventually come all the way down to 0. Now, how does this look? I see a line starting to form that follows a pattern of down 1 or down 5, down 2.5 every 1 or down 5 every 2. And so if I continue this pattern, I can follow that pattern all the way down until I get to the y or the x-axis. And on the x-axis, I see that we get to 16. In this case, I'm not going to draw a line because every time I ride is just 1 ride. If I draw a line, then I'm going to see that I'm taking decimal values that could be included here. And so I just continue the pattern. I find out the answer to my question: how many rides can Noah take before his card runs out of money? We see that 16 right here is when we're at an ordered pair of 16 and 0. Now, what does that mean? According to what we wrote earlier, x was the number of rides and y is the amount of money. So we can say this: after 16 rides, Noah is out of money. And where do you see this number of rides on your graph? On the x-axis. That's when we know that there's no more money left. So a quick way to read it and a quick way to go through it. Let's talk about somebody else. Let's talk about Han. So again, you can go to the interactive site to work on this. Here's a graph that shows the amount of Han's fare for every day of last July. So if we look at last July, we need to describe what happens with the amount of money or with the amount of Han's fare card in July. So let's take a look. Remember the initial value starts out over here on the y-axis. We know after 0 rides, Han had $20. And then we see after 1 ride, he still has $20. And 2 rides, he still has $20. And 3 rides, he still has, and 4 rides. And all the way across here, we see that he still has $20. So describe what happened with the amount of Han's fare card in July. Well, nothing happened. Han always has, or Han always had, because it's past tense, $20 on his card. That's interesting. Must mean that Han, we can talk about this and say, must mean that Han didn't ride or didn't use his card. So maybe he was getting to work or wherever he was going. He was traveling, maybe on a bicycle or walking or something else. But in this case, if we plot and label 3 points on the line, well, we already have 0, 20. Let's go ahead and we'll put one right here. That one right here is 8 and 20. And we'll go ahead and put one more over here. It is 16 and 20. Now, if we look at this case, we want to decide something about this that we say, oh, sorry, I didn't show those. We have to write an equation that represents the amount of money that was on the card. So let's consider the same piece that we talked about last time. We had to have a slope In this case, on the previous one, we had a slope that we recognized that it was the amount of money was going down $2.50 every ride. So knowing that X is still the number of days and Y is the amount of money on the card, let's talk about the slope. For every amount of money he's rising or spending $0 on a run that's going, in this case, up 8 every time. And we see that his y-intercept, B, is at 0.40. So then we need to be able to write an equation for this. When we write our equation, we want to simplify our fraction. Rise of 0, run of 8 tells us this. Y equals, remember M in this format, plus B would be Y equals 0 times X plus, oops, not 40, silly quilter. This should be 20. Now it seems kind of silly to go ahead and leave this value right here if we know that 0 times the number of rides is going to be 0. Because of that 0 product property, it's not necessary to even have that in there. And so what we should see with this is an equation that just says y is equal to 20. Now let's look at what that actually means. It says if y is the amount of days, or the amount of times, amount of money on the card, we can see that the amount of money on the card is equal to $20 for the entire month of July. So what values make sense for the slope of the line that represents the amount of Hans fare card in July? When we talk about this, what values make sense for the slope of the line, the only value that makes sense for the slope is anything. So any ordered pair with y being equal to 20. Because if I pick any other numbers, then I don't follow that same line, and I really don't have any other options. If you look back at the graph here, every single day is at 1, 22, 23, 24, 25, 26, 20, 24, 20, 27, 20, 29. Every single day in July is always at 20. And that furthers our evidence that he didn't use his card at all in the month of July. Let's go ahead and look at another one. Talk about Elena. She's borrowed some money from her brother, and she's going to pay him back by giving him the same amount every single week. Well, let's talk about a couple of questions. It says, answer and explain your reasoning for each question. Talk about the slope of the line. Let's think about the slope of this line. When we see where Elena starts, we see that we start right here on the y-axis. Let's go ahead and figure out what that value is. We have 0, and there's 15, 16, 17, 18. So 0 and 18 is this ordered pair. And then we see down here at the very bottom, this is 6 and 0. This is kind of nice because this is something that we can go ahead and use to determine the slope between two different points, calculate the slope. And so what we want to do is take my two ordered pairs, 0, 18, and 6, 0. We find the change in y, 18 minus 0. And we see 0 minus 6 for the change in x, which gives us 18 over negative 6. And we know that when we simplify 18 divided by negative 6, that tells us that the slope is equal to negative 3 over 1, or just simply negative 3. Now, how do you know whether the slope is negative or positive? When we see the outcome to this, the quotient of the change in y over the change in x is negative. We know that the slope is negative. So we can go ahead and go like this. Quotient of change in y over change in x is negative. We would see that that's a negative slope. We'll go ahead and just label like this. Negative slope, one qualifier is quotient of the change in y over change in x is negative. And the second thing is when we look at our graph, we see that the information, that the data moves to the right, but as we move to the right, we're moving down. So whenever we're reading anything, the normal way that we read is from left to right. As we read from left to right, we see that the data is decreasing. So we could say that data decrease, moving left to right. And we could talk about all just the exact opposite information with that when we're talking about a positive slope. Where we would see that the quotient of change in y over change in x is positive. And then we could see the second thing here is that the data increase from left to right. Now, there is some talk that I've heard over the years that talk about it looks like it's going uphill or going downhill. In this case, a negative slope looks like it's going downhill, which makes sense because Elena borrowed some money and she's paying him back. So we know that she borrowed $18 from her brother and that it took her 6 weeks to pay it back. So it only makes sense that the amount of money that she owes to her brother is decreasing over each week. And what we can tell about these pieces with this is some questions here. It says, what does the slope represent in this situation? If we talk about the value of what's here, the slope represents, we know that it's m is equal to -3/1. This is -$3 over 1 week. So we have to understand that she's paying money back. There's not such a thing as negative money, but we understand that she is decreasing her debt by an amount of $3 each week. So we could say debt decreases by $3 every week. We just talked about this piece. How much does Elena borrow? The y-intercept is at 0.18. So Elena borrowed $18. How much time will it take Elena to pay back all of the money she borrowed? We saw on the x-axis that we were at 6 and 0. So after 6 weeks, Elena will have paid all the money. There we go. So there's our case. This is where we apply this concept in real life. We see a lot of it towards money. We see it toward bus fares. The bus fare thing is actually really good correlation with what we do in real life, because with a debit card, we have accounts at our banks and we have a certain amount of money. And every time we spend money, that money comes out. So anytime we're spending money, we see that that would be a negative slope. We also see that when we're paying back a debt, we're paying back a certain amount every single week, or every month, whatever it may be, and that value decreases over a specific amount of time. We also see this in weather patterns. At the end of winter in Maine, the snow on the ground was 30 inches deep. Then there was a particularly warm day and the snow melted at a rate of 1 inch per hour. The graph shows the relationship between the time since the snow started to melt and the depth of the snow. In this case, what we see is 1 inch per hour. We would see a slope that, since the graph is going down -1 inch per hour, we would see that's a depth of decreasing 1 inch with respect to every single hour. And so the vertical intercept where we start is right here at 30 inches, or 0 and 30. After 0 time, we started with 30 inches. And then as we continue on, we see that for every 1 hour, we decrease by 1 inch. And we see that pattern follow right here. It's nice to see a different rate of change as -5 inches over 5 hours. But we know that that rate of change is still equal to -1. We see that a -1 inch over 1 hour is the same thing as a -5 inches over 5 hours. Graphs with negative slopes, they pretty much demonstrate not pretty much, they always demonstrate some kind of quantity that's decreasing over time, like the depth of snow or the amount of money on the fare card, or like I said, the amount of money on a debit card. But slopes can be positive, they can also be negative, but the big thing that we didn't really talk about is a zero slope. When we see a zero slope, it means that no change in y is ever occurring. It's simply the x value that's changing. So like when we talked about before with our friend Han, his data was consistently staying at a flat line. And so we see that Han didn't spend any money off of his fare card for the entire month of July. We could see something like this, where this example here, Elena won a contest where the prize was a special pass that gives her free bus rides for a year. Her fare card had $5 on it when she won the prize. Now, here's the cool thing about it for her is since she won for a year, her money is not going to be spent on it. She could have had $5 on the card, which normally would have meant just 2 rides. But in this case, since she won for a year, her fare card balance would just look like this. She would constantly have that $5 no matter what, because it's not costing her any money to ride the bus. So in this case, the vertical intercept is at 5. We start right here at 0.5, indicating she had $5 on her card. And the slope of the graph is 0, since she doesn't have to use her fare card for the whole next year. So when we talk about linear graphs or linear equations, we have graphs that are positive. Just to do a quick recap, positive slopes, if we were to have an x and y axes like this, positive slopes just follow through at lines like that. Negative, we see that our lines intersect the x and the y axis from left to right, moving in a pattern that appears to be going downhill. And then we have a 0 slope when we talk about a line that is parallel to the x-axis, meaning that there is no rise. It's constantly just going to be a slope of 0. All y coordinates equal the same value. So that's it for today. Good luck on your homework. If you need any more help on this, please give me a shout out and I'll help you out. Take care.